chemical reaction with an equation like this. So what it really means is the ratio between these chemicals are 1 to 1 to 1 to 1. That's what it's all about. So just that also means if I need to make, say, 2 moles of Z, then I need 2 moles of X, right? Or if I have like 5 moles of X and then 6 moles of Y, well, since it's 1 to 1, right? So that means there's extra 1 mole of Y that is not going to be used. You still end up with 5 moles of Z and 5 moles of W, right? So 1 extra mole of Y is left, right? So that is the basic concept here. Next, we'll look at some actual problem, okay? So let's look at this guy here, all right? So we have an equation, with the reactants, right? This guy react with this guy, result in this guy and this guy, right? So first thing first, we need to balance the equation. So I would look at the NO3 here, right? So there's only one of these guys here, so I just times 2, and we are actually done, because 2 sodium here, so it's 1, 1, 1, 2. So that's the very first step, right? Now, we know there is 148 gram of Na2CO3, right? And we know that the molecular mass of this compound is 105.99. Yeah, you just look it up, right, from the periodic table. So that is 1 mole of this chemical, and 1 mole of Na2CO3 also correspond to 1 mole of CaCO3, right? There's a 1 to 1 ratio. Now I have let's say I have 1 liter of CaNO3 to, and that's 0.75 mole of CaCO3. What am I writing? Oh, I know what's wrong. Like this. Sorry about that. NO3 2. Okay, there we go. Yeah, that's because of this. 0.75 m means every 1 liter of the solution have 0.75 mole, right? So that's this guy here. So after all this calculation, so you multiply this guy with the 1 and divide by these guys, you end up with, and it's 2 significant figure. So anyway, this calculation result in 1.862 blah 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 blah, and because there's 2 significant, right, so we round it out to 1.9, and the remaining unit is liter. Okay, so that's 1.9 liter of this solution. All right, we'll look at the next problem. It's actually a set of problem. we got it's the same chemical reaction, but we involve 4 different scenarios. So we'll look at them one by one. Okay? So, um, so the good news is this is already balanced. All right, the equation is already balanced. So what we need to look at is just the amount. All right. So let's look at scenario A. All right. So we start with 285 milliliter. Okay. And well, we want to convert to liter, right? 1000 milliliter is 1 liter, right? So now we get it converted to liter. And then we also know that, all right, the molarity is 0.2 m, right? So that means 1 liter we get 0.2 molar of KCl, right? And remember, it's all about the ratio, right? The ratio for every 2 moles of KCl it will react with 1 mole of PbNO3 too, right? So 2 mole of KCl, 1 mole of PbNO3 too. All right. And finally, we know that the molarity of the PbNO3 is 1 liter of the solution have 0.1 mole of PbNO3 all right. So hit your calculator and it comes out to 0.285 liter, something like that. And 3 sig figs is needed for this calculation. So we keep 0.285. Yeah, it turns out, it's actually the same as 285 milliliter. Well, that's the same volume of the KCl solution. If you think about it, it makes sense, right? Because the ratio is 2 to 1. So this is 2 to 1. That's why the volume is the same, right? So scenario B, we have, we start out with, let's say, 245 milliliter, right? And then we do the conversion. 1000 milliliter is the same as 1 liter. And then, for 1 liter, we have 0.250 mole of PbNO3 right? And then, the ratio of PbNO3 to KCl is 1 to 2, right? And then, again, 1000 milliliter is 1 liter. And then we got 25 milliliter, right? After all these calculations, it comes out to 0.9 mole of KCl per liter, right? So that's the molarity, 0.9 m, right? So far so good, right? A and B, we're done. C. Okay, so we start with 2.5 gram of the PbCl2. Okay, 2.5 gram of PbCl2. Again, we look up the molecular mass is 278.11 gram of PbCl2 is 1 mole of PbCl2. Okay, and 1 mole of PbCl2 is 2 mole of KCl, right? Look at here. Every 1 mole of this, we need 2 moles of this, right? And finally, 1 liter 0.1 mole of KCl, right? That's the molarity. Okay, so after you hit the calculator and you round things up, right, to 3 sig fig, right, and we get something like 0.180 liter. Okay, and finally, the last part, I'm running out of space. Let me use this portion. And so D. So we start out with 0.5 gram of PbCl2, okay? And from C, we already know it's 278.11 gram PbCl2. Give me 1 mole of PbCl2, right? And next, we know that 1 mole of PbCl2 is 1 mole of PbNO3, 2, right? 1 to 1. And we got 1000 milliliter equals to 1 liter. Then we have 25 milliliter of the good stuff, right? 25 milliliter. So it's 0.072 mole of PbNO3 per liter, right? So that the answer is 0.072 m. And again, let's check the sig fig. We have 3, so it looks good. Okay, thank you for watching.